So we are going to talk about the application of Squeeze Theorem. We did some examples in class, and here I just want to make sure that you can review these contents when you need to. And the theorem says that, if G is between F and H, near A, in the neighborhood of A. So you can see it doesn't have to be the whole place. It doesn't have to be in the entire domain of all three functions. In this area, you can see G is higher than H, right? So it could change at other places, but as long as in the neighborhood of A, we have that relationship, which is described as G is between F and H, that will be fine. Then there's basically two major conditions here. The first one, of course, G is between F and H. The second one actually implied three conditions. Okay, imply three conditions. So I'm going to put a note here. Okay. If you talk about that conditions, the first one, if F and G, H, they're in this relationship. The second condition actually involves three conditions. Okay, this limit exists. Okay, and this other limit also exists. And thirdly, the two have the same limit. The two have the same limits. Okay, so this is the two major conditions. The second condition implies three. So when we check these conditions, they need to be all satisfied in order for us to apply the conclusion of Squeeze theorem. Okay, so in the case of the first one, right, to apply Squeeze theorem, we just have to find, because we're given, say this is a G, right? This is a G, and we need to identify the F and H, so that G is in between in a certain neighborhood. Okay, so in this case, as we understood, sine function is bounded. Sine function is bounded. It's for any input sine takes, its absolute value is is less than or equals to 1, or we prefer to use the other inequality set that is between -1 and +1. And this is true for any input. Okay, and of course, this function's domain does not include 0. So 1 over x can be any number other than 0. So certainly that is still true. This will be true for any x, And certainly it will be true for x not equal to 0, right? And in our case, here, x is not 0. This is just to emphasize that the domain of this function is not, it does not include 0. And then we will multiply x squared on every side of this inequality. Okay, x squared is positive or 0. Since x is not 0, x squared is positive. Okay, so x squared is positive. So we're going to multiply that on every single term. Okay, here we're multiplying a number that is positive. Okay, because x is not 0. Okay, can we do that? Well, in this case, we're actually using principle number 4. And it's also, the extended principle that for inequalities. So here I'm going to put a little note here, right? If A is less than B, then A times C is less than B times C, provided that C has to be positive. Okay, C has to be positive. If C were negative, we have to switch direction. Okay, I trust you guys know that. Okay, but if you have a question, please ask me about that. So now once we get to this point, right, we simplify, right, negative x squared, and this 1 times x squared. So we have identified the f and the h, right? So the function we are working with, x squared times sine of 1 over x, is squeezed in between these two. And then we can take limit. We take limit of, the function below, right? And that's a direct substitution. That's going to be negative 0 squared. And that's going to be 0. And the other one, limit approaching Sx approaching 0 for positive x squared. And that's going to be 0 squared. And that's 0 again. So by Squeeze theorem, okay, the limit is going to be 0. The limit is going to be 0. And the graph of this, and I took the excerpt from the textbook, right? So x squared is the one above, negative x squared is the one below, and in between is the sine 1 over x. So you can see clearly that Squeeze theorem applies in the neighborhood of 0. Number 2 is similar. Number 3, cosine has similar properties. Cosine has similar properties. Okay, the range of cosine is also between -1 and +1. Okay, so when we prove that, we started with the cosine. Okay, cosine pi x. This is between -1 and the +1. And this will be true for any real number. The domain for this function is all real numbers. Okay, so 0 is also included. And then we multiply x squared on every side. Okay, so that will still be true because x squared, okay, x squared is at least 0. So we multiply x squared. Okay, so we multiply x squared on every side. Okay, so once again, x squared times cosine 20 pi x is squeezed in between negative x squared and the positive x squared. So we can apply Squeeze theorem one more time. Okay, so that limit, we have done it here, right? So we're going to cite that limit here. So as a result, by Squeeze theorem, the limit of this function is 0. The limit of this function is 0. You can see we follow some logical steps. Just be sure that every step you have a reason, right? This is, we use the range of cosine. And we apply the properties for inequalities. We can multiply every side by a non-negative number. And we have identified the two functions that's squeezing the given function in the middle, and apply apply squeeze theorem. Okay, just basically check those conditions. Check those conditions. And these are two other questions we've seen that from, they're all from the textbook. And number 4 is slightly differently, is because it's already given. It's already given the F is between the two. So the proof is going to be pretty straightforward. All we have to do is that we know it is in the neighborhood of 4, and we know this relationship is true. X is greater than equal to 0. So in the neighborhood of 4, we can assume this relationship is true. Okay. And then we just take limit. Okay. So we assume this relationship, okay, is true in a neighborhood of 4, in a neighborhood of 4, right? And we just take a limit. We take a limit as x approaching 4 on the function that's below, which is a 4x minus 9. And that would be a direct substitution because 4x minus 9 is a polynomial. So minus 9. 16 minus 9, that's the 7. And we will take a limit on the function that's above f. And that's going to be x squared minus 4x plus 7. And substitute, right? Direct substitution, that's going to be 4 squared minus 4 times 4 plus 7. So the answer is 7 again. The second condition is satisfied in Squeeze theorem. Then we can say by Squeeze theorem, that this limit is equals to 7. That's it. That's it. Number 5 is similar. Number 6 is similar to, 1, 2, 3. 1, 2, 3. Number 7 we covered in class. And here I wish to cover it one more time so we have it in the records just in case you guys need any help with it. Okay. In this relationship, right, first we need to understand the domain. The domain for this entire function actually is x greater than 0. So domain discussion, right? On sine pi over x part, to make sure pi over x is is meaningful, x cannot be 0. So this condition must be satisfied. And the other condition we need to satisfy, we need to make sure square root of x is well defined. So x has to be greater than or equal to 0. Combine these two, the domain is x is larger than 0. Okay, so the domain is x larger than 0. So no wonder the limit is taking, we are approaching 0 from greater than 0 because we cannot approach 0 from less than 0. The function would not have been defined, right? Okay, and here we get to use a couple of important properties. Okay, sine of pi over x. This is also between -1 and +1. So this is true for any real number x. And it certainly is true. It's true for our current domain. Okay, and it's true for x greater than 0. It's true for any real number. It certainly is true for x greater than 0. Okay, and secondly, we're gonna sine, sine is the power to e. So we're gonna apply these as the power. Okay, the question is, can we still maintain the same relationship? In other words, if I use the this inequality, right, to raise the power, will this still be true? The answer is yes. Why? And this reason is very important. The reason is very, very important. The reason is that e to the power of x is an increasing function. Only for increasing function can we do this. Okay, if it were not an increasing function, we will not be able to do this. Okay, we'll have to reverse the inequality. Okay, so this from this step to the next step that is true is because e is an increasing function. And next, right, so we're gradually moving towards multiply square root of x. X is positive, so square root of x is positive. So on this inequality, which is true for all x positive, then we can multiply x. We can multiply by x. Okay, so that would be true. So because this is true, and in addition, e to the power x is an increasing function, so therefore, and now square root of x, we multiply on all sides. The square root of x is also an increasing function. So this will continue to be true. Okay, and e to the power 1, we can remove the 1, right? We can remove the 1. And e to the power -1, of course, we can leave it like that, or you can write 1 over e. And now we found the function is squeezed in between these two, right? And then we take limit as x approaching 0 from larger than 0 on e to the power -1 times root x, and that limit is a direct substitution, it's 0. And the next one, right? The next limit is a function from above, to remove that, and that is also equal to 0. Then by Squeeze theorem, the function that's squeezed in between has a limit, which is 0. Okay, so these are the examples of applying Squeeze theorem to get the limit. Yeah, these are the homework. Okay, I will put up some more exercises for you for this week. So until next time, thank you for watching.